Very good morning. Welcome to this first of three workshops on the Semantic Treehouse, a topic that I am myself not at all an expert in. So that's why I'm quite happy that we have Wouter van den Berg here with us today. I will hand over to him in a minute so that he can guide us through this workshop today. As you know, that indeed we will have some very technical aspects that we will go through, but Wouter himself is, I think, best placed to explain you in detail, because I'm saying words like Docker, but I have no idea what they mean. So I'm the only thing that we did here within the framework of the ZeroW project is bring these lovely people together, and now we are very happy to see what the result will be. We can do a short tour of the table later on to make sure that we know a bit who is who. But first, I would like to give Wouter the floor to introduce himself, his colleagues, and our plan for today.
Thanks, Lisa. Welcome, everyone. It's good to see so many people here. My name is Wouter van den Berg. Together with some of my colleagues, who I'll introduce later, we will guide you through the deployment of Semantic Treehouse today. This is part one, as Lisa said, part one of a three-part workshop. The second part is tomorrow, and the third part is the day after. I see there's still people coming in. Welcome. So today is a quite technical day. That's to say, we will dive into and demonstrate how to deploy Semantic Treehouse locally, or maybe even on your own Kubernetes cluster. Before we start, I would like to show you the agenda for today. You can see that today is a session in the context of the Zero Waste project. I'm happy to have met Miran and others last year in the context of that project, together with my colleague Erik. And actually, our contact last year has, I think, led to this moment, where we are here with 20 people to discuss Semantic Treehouse, a open source web application developed by TNO to help with data interoperability challenges. We will not discuss the nature of the tool today that much. That will be for tomorrow, how to use it, what are the tasks that you can best use it for. Today is very focused on the deployment part. It is structured like so. As you can see, tomorrow we'll look at how to use the tool, and then the third day is about what the wider context. We'll discuss different data ecosystems that we have deployed Semantic Treehouse, and how these different characteristics of the ecosystems have influenced the further development also of our platform. But for today, the agenda looks like this. It is very simple, actually. It's just two parts with a nice break in the middle. The first deployment method is with Docker Compose. This is simpler, but I guess less flexible. And the second part will be about the deployment method 2, which is through Kubernetes and Helm. I will hand over to my colleague Jan-Pieter Wijminga and Jesper Kuiper. Jan-Pieter will lead us through part 1, and Jesper will lead us through part 2. I would like to maybe say one or two more sentences about Semantic Treehouse. Perhaps there are some of you who have never heard of it. You must know that Semantic Treehouse is a platform developed in-house at TNO. TNO is a zero waste project partner, a Dutch research and technology organization. So our purpose is not to develop software per se, but when it comes to our work on making supply chain or other value networks interoperable, in particular the semantics of the data interoperable, we have developed Semantic Treehouse to help with some of the challenges we faced in that. And this, as the years went by, has grown into the platform as it is now. And in some cases, we host this platform for a few sectors in the Netherlands. We are on a journey of open source. You will know that the open source, or the repository of Semantic Treehouse is completely open source. And since I think a week or two, we have also transferred our issue management about the platform onto GitLab.com, the open platform. So that means that if you have some issue, if you have a suggestion, you can go to gitlab.com/semantic-treehouse, and you can help us report the issue and help us improve the platform further. Now, without further ado, I would like to start the demonstration, and I give the floor to Jan-Pieter Wijbinga.
Hello, everyone. My name is Jan-Pieter Wijbinga. Hope you can hear me all. I will be showing the first part of how to deploy Semantic Treehouse, and that is the Docker part. I'll share the PowerPoint. My name is Jan-Pieter Wijbinga. I'm scientific developer at TNO for 13.5 years, and my background is also in conceptual modeling. So I like a lot about Semantic Treehouse that it does conceptual modeling, even though not being too, so to speak, ontological and scientific, but also into message models that are being really used, like XML, JSON, JSON schema, and we're working with that. So it's a pleasure to present this today. There are two ways of installing, and I'll introduce the Docker Compose part. The files are located here at this link. I'll use the link as well to execute the first command. So I'll first give an overview of the architecture. There are, in Docker Compose terms, 6 services that can be run. And these are the most important one is the app. That's in the bottom. There's a laser pointer, right? So here's the app. There's a MariaDB database, which is open source variant of MySQL. You might be familiar with it. And then in this part on the right, we recently introduced. It's about emailing, but later we plan to do more worker tasks. As I said, there are 6 services. The part on the right is more about mail notification functionality that you might not use if you are running it locally. The app uses a database for some of its internal storage, like the specifications and like the content in text. Any uploaded files, uploaded images, maybe uploaded artifacts are stored on a different volume. So there are 2 Docker volumes. And it's not really necessary maybe to explain exactly, but this is basically the distinction. Some data comes from the database, so that means that there's a volume that holds the content, and if users can also upload, so we're dealing with a user platform, a bit like GitLab, you can upload your own PDF attachments, for example, or images. We're also hosting a Dutch norm. There's a lot of nice images about viaducts and buildings and everything. That goes into the app data, but then the text about the norm goes into the database. On the left, there are 2 odd jobs that are that have to do with migrating the application, because we're adding so much functionality all the time. So that's the migrator that updates the database schema if it's needed, but you need not worry about it because it's like an automatic process when you do Docker Compose up. Then there's an installer that we only run once. That's the I'll show. Now we see the same picture, and this is the legend. Some pre-made files are on gitlab.com. So that's here. There's a Docker Compose. There's default variables. There are some manual steps that we need to do. It's not a lot, but I indicated them with purple. So this part I'll first show later, and then we do run, then the magic happens, and this is what you get. And I added here, this should be reachable at your local host. Yeah, I was just saying in the introduction, like we not have a tool that is like has a Windows installer or Linux installer, like TopRate or Protege or whatever. It's really a community platform, so it's a website, and that makes the deployment a bit more difficult, but it's also more fun that way. You can work together with people. So that's why we have a web server. Of course, when you're running a web server, you need to do a lot more work, but we're taking it a step at a time, which is how you do innovation, in my opinion. So first we'll have a local host reachable, then you can play with it in your own browser. So this is what I'll do now in the demo. Step 0 is we clone the repository, we move in the right folder, we copy the variable files, we do docker compose up or up -d if you're more comfortable with that. Up shows us the logging. And then we'll execute the installer, and then notice the RM. That means that the container that runs the installer that you only need once, that is removed after it's being run. So now I can press Alt-Tab and go to the prepared VS Code, which is for me at least the preferred editor. Yeah, you see my code folder in the WSL of Windows. On the right, you see the terminal. Please indicate if I'll just make the text bigger. I'd like to have the text big to hopefully save the eyes a bit. Let's go to the browser. If you press the link in the presentation, you will be going into our gitlab.com. Yes, you can see I'm not signed in. This is the page that you reach, and in the bottom there's the README. So this says the minimal deployment demo, the preliminaries, so blah blah. The preliminaries are Docker Compose. Because I'm working in Windows here, let's check that I have Docker running. So this is the Docker desktop. Yeah, I wanted to delete this for the perfect demo effect. I delete all the images that are already there. So this is a clean Docker desktop that you'll get if you download, not signed in. There are no containers, no images. Let's see, I also have to delete the volumes because I prepared the demo, obviously. Now, there's a link here to clone. If you press with SSH, it asks for the key, which I have, but this one doesn't ask for a key. So cloning with HTTPS doesn't ask for a key. So I'll clone the repository then. Thank you for the push forward. I'll open the code again in this, let's see, this window. So there are two folders, the Docker and the Kubernetes. The Docker Compose I'll show. It's good to inspect which services there are. There's the migrator, the installer, the database, the app, the mail catcher, and the consumer. Yeah, so let's go ahead. What we can first do is Docker Compose poll. Just make sure we get the images. And now it says I can't download the images. This is because we don't have .env yet. This file contains the variables that we need. In the Docker Compose, they're substituted. So and they can be They can be edited as you like. The script creates one user for the, let's see, the front end that should be able to, or the backend that should be able to access the password, the database. It creates a root password because we're setting up a new MariaDB, and you can specify an app version here. And this command of pull, it failed because the app version was not inserted. So now I copied it into a new env file. So I'll try again. And we're almost done, as I'll show. I'll show the Docker Compose command. There are some dependencies between the services. So what will happen is the web app will wait for everything to complete. So we need the migrator, we need the database, we need all the other components, not the installer, that will not run automatically. So I'll now be typing Docker Compose up. It will block the terminal, that's fine. Oh. And it will show me the logging of all the services. So this will be a bit of information overload maybe. Let's see. You'll see the database starts right away. And the database is initializing a new database itself, a new schema as well. Now the migrator runs on the database. And if that's done, then also the startup script will create a user. The consumer will wait for the incoming messages from the platform, and then the app is ready to go. So Apache says its version, and this is the indication that we now have a running service. If you now go to the website, sorry, then it will already show something. Give an error, please log in. And if I click this, you'll see an error, the account does not exist. So this is what we'll tackle with the second command that will run now. And this command is Docker Compose run, then remove the container afterward because we don't need it afterwards, and then the installer in the correct folder. It's pulling the image that does the request. So we're running the application in debug mode. This is causing us to have a way around the normal authentication process. Obviously, not everybody needs to be admin if you host this, but for local, we added this option. It's a flag in the Docker Compose. So now it gives this strange message, which means it's okay. If I go back now, you see it seems I'm not logged in, but this is a refreshing issue. So I'll refresh, Control-R, and now you'll see that the platform is up and running. We can create new specifications, and we're done. So this concludes the first part of the demo. Are there any questions about this?
It looks so simple.
Well, yeah, you can get stuck somewhere, so people follow along. But it's
It is simple, but I have a question. Probably I have too old version of Docker Compose. What is the minimum required version of Docker Compose, if you know? Because I have some error where I got error where I tried to run Docker Compose.
I don't know the minimum required version. It's higher than you have probably.
Yeah,
I'm running
okay.
running everything on latest, but
okay. But my colleagues we have chat that they could run the treehouse, and I will check my versions later and so on. But yeah, we are good.
Okay. I'm also curious to hear about some experiences, some success experiences. Always helpful. So did somebody manage to to get it?
Yeah, it works.
Okay. Oh, great. Yeah. And then if you're a real developer, then you'll say, okay, and what now? But this is not for today. I could speak more. Yeah, maybe like Docker Compose down, and then you can stop the service. And in your Docker desktop, you can remove the images, and also there are 2 volumes. So if you, I'll show this in Docker desktop too. So what it created now is one Docker Compose application. You can see it's a stack in the terms of it. You can see there's an app that has a port open on my machine. There's a database with a certain version. And there's the migrator stopped because it stops after the startup. There's a consumer and a mail catcher, which is about sending emails. And the mail catcher also has a web interface to show the emails the platform sends. This is something we recently added because users want to be notified when there's a platform, there's a change in the specifications. So this is also what you get. And then the images that it downloaded are here. And the volumes that it created, the app data is 0 because it contains the user uploads. The DB data, the database is now currently 230 megabytes, and yeah, that only stores text. So if you're sizing, like a couple gigabytes should be enough. And if you want to clean up, then cleaning up this stuff is okay. So I have a tendency to say we're done, and if there are no more questions, then we can proceed. Wouter?
Yes, thanks. So I am you and Jesper are among our developers in our team. So this work I have not done, I think, once. And I know that in the second part, we will show you our second deployment method. But can you tell me the rest, how or if you still use this deployment method in your work with Semantic Treehouse?
In Docker Compose, I use that sometimes for features that we're building. Yes.
And I know that we often have this way. We have an empty database, so there are no specifications yet that you can reuse. This is normal, of course, because Semantic Treehouse is made without a certain domain in mind. So it can be used in the energy domain for energy data, or it can be used for agricultural data. So that's why it makes no hint or commitment to any domain. For zero waste, of course, we have a deployment at zerow.semantic-treehouse.com. Or it's .nl, I think, by the way. Anyway, so how would you recommend people filling up this first locally deployed environment?
There are several ways where you can fill an environment. So as you can see, depending on your interest, you can start with importing or creating a new message model. We have a way called bottom up, which is really click your own message model together. We have a way called a JSON schema, where you point to a JSON schema or insert it, and then later you're able to point to a class in the JSON schema and start with new message models from that. We have a way called ontologies, where you paste the working turtle file, and then you can specify a root class, and the wizard will give you the option to make a message model out of that root class and the outgoing properties of that. And a simple way could be a technical standard that is doesn't have a formalization other than PDFs. So if you want to share, and this is how Semantic Treehouse started, your PDF specification, a lot of norms are still hosted maybe in PDF. Then you can also choose to do that. Then you get a bare specification with attachment possibilities, and you can also create issues around this so that you don't do the discussion over the standard with emails, but also with issues. With discussions.
Thank you. That's great. And I think this is a nice moment to, if you can pop up the menu again, Jan-Pieter.
Yeah.
Tomorrow we will go into how to add specifications using this menu with Semantic Treehouse. So that's the distinction between today's session and tomorrow's. So in particular, the first option, adding message models, and the third option, adding ontologies, and how they are related will be the subject of tomorrow.
Yeah.
But let's continue with method 2 of the deployment of Semantic Treehouse platform using Kubernetes and Helm. And with that, I'd like to give the floor to my colleague Jesper Kuiper.
Yes, thank you. Yeah, so I introduced myself beforehand a little bit. First of all, I have a bit of a cold, so if I'm not completely understandable, just feel free to give me a ping so I know I have to talk a bit louder or something. So now we're going to the Kubernetes deployment of Semantic Treehouse. Coming from Docker Compose, this is stepping it up in terms of complexity, but also in terms of flexibility. When you think about monitoring, security, continuous deployment, Kubernetes is the better way to go. But if you're just playing around with Semantic Treehouse also for the sessions that follow, then we recommend to use the Docker Compose deployment. But when you want to actually get Semantic Treehouse up and running for a larger audience, let's say, in a production environment, then we recommend using the Kubernetes deployment method. So I will share my screen now. There we go. So for the Kubernetes deployment of Semantic Treehouse, we provide a Helm chart. Helm chart can be seen as the Docker Compose file for a Kubernetes application, so to speak. Here, can you guys see my cursor right now? I think right here you can see some of the services that you also saw in the overview of the Docker Compose, the Semantic Treehouse application, and the asynchronous consumer. The migrator that is now called an init container, which means that it is run every time that the Semantic Treehouse app is started or restarted. And the installer is now called a post-install job. So that means that it's only run whenever the entire deployment is installed. But if you want to deploy Semantic Treehouse in a production environment, you need more than this. You need a Kubernetes cluster, of course, and then from the ingress we need an ingress controller. If this is gibberish, then don't think too hard about it. But this is some stuff that you need to run Semantic Treehouse completely in a production environment. Of course, in the end, there should be some domain somewhere that you can use to access the application. You need a database. We do not provide a database natively in the Helm chart, because if you're running in a production environment, we assume that you want to set that up yourself with some replication scheme or whatever. So we are not touching that in the Helm chart. And the mail service as well. Jan-Pieter briefly touched upon the mailing functionality. Here you need to provide your own service that can send mails to the outside world. But for this demonstration, we do a couple things already. We use a third-party chart, another Helm chart. So for the database. That's just a MariaDB Bitnami chart. That's just a database with another service. The service in Kubernetes is the way to communicate between different deployments that exist within the cluster. And we have certain files prepared that you can use to deploy the Semantic Treehouse environment, that you can use to deploy the database, and that you can use to have the secrets, the username and the passwords that you need to access the database, for instance, available to the Semantic Treehouse application. And as well, we don't use ingresses or domains here. We just do port forwarding to a local host, the same as it was at the Docker Compose setup. So yeah, let's go to the demo. If you need a testing Kubernetes cluster, just a local cluster for later, you can use things like Minikube, K8s for Ubuntu, or Kind Kubernetes in Docker, where you can get a Kubernetes cluster running inside Docker, which is quite neat. So now I will go to my VS Code environment. Here I have the setup demo repository already set up, and I'm in the Kubernetes folder here. And I will just go with the flow of the README, and that should just be enough to install the Semantic Treehouse application in the demo setting on the Kubernetes cluster. So the first things we need to do is add the Semantic Treehouse. Oh, that's not what I meant. The Semantic Treehouse and the Bitnami repositories to Helm. So Helm knows where to find our Helm charts. So I'll just copy this and run it. And now it updates these repositories. And then the first thing that we do is to create a namespace in which we are going to deploy Semantic Treehouse. So that's this one, create a namespace. And then we actually set the namespace as the current context. And that just means that Kubernetes will do anything from the context of this namespace and not any other namespace. So right now I already have a cluster, so I will use the namespace demo that I already have. So I will just set that to the current namespace. There we go. So now when I try to get pods, that's the containers in Kubernetes, then you see it's only looking inside the demo namespace here. From this point on, we have created an install script that just does all the steps that you need to deploy Semantic Treehouse. I'll just quickly get that here. So this does a couple things. First, it applies the secrets. If you remember, that's the, I can briefly get that up here too. That is the username and password of the database. Actually, we use two database users inside the Kubernetes environment. One of them is the user and the other one is the migration user. That means that the migration user can actually create new tables and create new or create columns inside tables, or alter columns, or remove columns. And the SDH user can only alter the data inside the tables. So that's just an extra security feature where the Semantic Treehouse application cannot change the tables themselves, can only change the data inside the tables. So secrets use base64 encoding, so this gibberish is actually SDH migration user, and that's the same for this. And it goes without saying, never use password 1 and 2 as actual production passwords, but that's just for demo purposes here. So the first thing we do is create those secrets, and then we are installing the MariaDB Helm chart. We use a specific version because that's what Semantic Treehouse expects. We use MariaDB version 10.6, and that's present inside this chart version. And we use the MariaDB values for that. That's just some configuration that sets up MariaDB in such a way that Semantic Treehouse knows what to do with it. So that is the MariaDB part, that's the database, and then we install Semantic Treehouse with the Semantic Treehouse values. So yeah, this is the values file. This is just the configuration that you need for Semantic Treehouse to run in the Kubernetes. Here you can see the local host and some extra settings that we can just take for granted right now. Here you can say we refer to the secrets that are created in the secrets.yaml file, so that it knows where to get the credentials of the database. So that's basically all that does. So let's just run that script. So here first we'll make the secrets, and now it is actually installing the database. And what I can quickly do, I have a K9S. That's a nice way to monitor what's happening inside a cluster. Is this readable as well for all of you? What's in the table or in the terminal here? Here you can see MariaDB is running, and it's not ready right now. So it is currently initiating the database. And when that is ready, here this will pop up as ready, and then we'll see the script as well advancing to the next step. I'll quickly put this one on a separate screen. There we go. Okay, so now you see the MariaDB is active, and we are creating the schema, and that means that we are adding the correct database inside the database. That's just some MySQL things we need to give a name to a database, and from that perspective we are working. So that's completed, and now we are updating MariaDB to add some configuration that Semantic Treehouse expects. And now it's running again, but the readiness probe is not yet completing, so it is not ready yet. So if we wait for that for a sec, then we will go to the next step of the script, and that is actually installing Semantic Treehouse. And there we will see also some interesting stuff happening here. So this takes a little while. There it goes. Now it's running, and now we'll see Semantic Treehouse getting up. Currently pending, so it's pulling the chart. And here it's doing the init container. That's the migration step. So we saw that in the Docker Compose as well. It's now migrating the correct tables inside the database. This takes a little second. And when the init container is done, we'll see it going to container creating status in a sec. So this is just, there we go, pod initializing. Now it's creating the container, it's running, and here we see the install script. So this is the installer that we had to run manually in the Docker Compose setup. Here it just runs it when Semantic Treehouse is up and running. So now we can see that the script has exited successfully. Now the only thing we need to do is port forward. In Docker Compose, the port forwarding to port localhost 8080 went automatically, but here we just have to say to Kubernetes to forward that port for us. So here it is forwarding, and now if we go to the localhost, let me quickly get up a browser here. There we go. 8080, and this should bring up Semantic Treehouse. And now with the same deal, clicking on admin, and here you get the same cryptic message that just says everything went correctly. And now refresh, and there we go. We have Semantic Treehouse up and running, but this time inside Kubernetes. So if I quickly go back to this one, here I can go back to the README. We can see what it all created for us. We can use this kubectl command. Kubectl, that's the Kubernetes control program that you can use to interact with a Kubernetes cluster. Let's create a new terminal. Get it a bit bigger. There we go. So here we'll see what has been created for us. So here we have the services. That's the constructs that we use to communicate between different applications that are running within a cluster. So we get an internal IP address that's within the cluster used to communicate. The deployment for Semantic Treehouse that just makes sure that there's always one Semantic Treehouse application up and running and ready. MariaDB uses something called a stateful set. That just means that MariaDB maintains a state, and the state in this case is the database. So that's just a distinction that Kubernetes has in there. And here we see the pods. The pods are the actual running containers. It can have multiple containers. Here you see that Semantic Treehouse has two. That is the Semantic Treehouse application and also the asynchronous consumer that is used for the mailing functionality. And MariaDB has a single pod. That's just a database. And these two are the jobs that we created. So this is the schema just to create the initial database configuration. And this is to create the admin and actually initialize the database for us. And then the secrets, Helm also creates some secrets, but here we see the user pass for migration and the normal Semantic Treehouse user, and MariaDB actually also makes a secret. So that's basically getting a Semantic Treehouse application up and running inside Kubernetes. Are there any questions so far?
Can you share with us some of your thoughts about different ways? Because you mentioned the word production in this demonstration. Jan-Pieter in the first method did not mention production that much. Can you share some thoughts about how you would approach actually putting up Semantic Treehouse to be used in production by others?
Yeah, then I would go back to the slide for a little bit. I think this one shows pretty much what you would need for a nice and functioning production environment. So we have the Semantic Treehouse deployment, but the most important part is getting that to the World Wide Web.
Yeah.
So from that, we go to the domain, and we need a Kubernetes cluster running somewhere, and then connecting that to a domain that you have. And then as well, there is the database, and that really depends on the amount of users that you expect to have. You can use the Bitnami chart that I used in this demonstration. That will work for most intents and purposes. But it could also be that you already have a functioning database somewhere, and then you can add a new schema inside there and work from that. Or you can use something called the Galera cluster, where you can also have replication, so that if one database application fails, the other one can pick it up. So I think these are the most important things. I think the mail service is completely optional, depending on whether you want to have that functionality enabled. Yeah, does that answer your question?
I think it's useful to make the distinction indeed between deploying Semantic Treehouse locally to be used in, research programs, for example, and at the other end of the spectrum, there's of course the Semantic Treehouse as a service that TNO provides in a few cases. Not too many, because that's a bit out of our comfort zone, or at least out of our organization's profile. But indeed, providing Semantic Treehouse as a service to be used by 100, 200 unique business users per month is really a different thing than our more early research that we do, applied research with Semantic Treehouse. Our zero waste environment, I'll just point to it in the chat by now. It's high time. This is an environment that is more somewhere in the middle. So it's in the Horizon Europe Zero Waste project. So it's not exactly research, but not exactly production either. Although we have set up it in the same way as other environments that are in more intense use. But tomorrow we will show you the Semantic Treehouse deployment that is maybe used most intensely, which is the flexible staffing environment. And then you'll see that it's quite necessary to have all these green components, including database backups, because it would be quite catastrophic to have any data loss after we have created these data standards with the sector for years now. So different contexts where we provide and host Semantic Treehouse.
Yeah, and I think where the Kubernetes deployment thrives is allowing for all those different kinds of setups while using the same kind of general architecture. Where in Docker Compose it can be quite static, where you just have the thing that you made inside the Docker Compose, and that's it.
Yeah.
So that's the flexibility component.
Yeah, and in our case, and I don't know about, for example, ITC, but in our case, we really need this flexibility because of the different requirements of each context or client that puts on the environment. Okay, I have a feeling that we are reaching the end of our session. We have showed you the method 1 of deployment with Docker Compose, and now Jesper has been so kind to demonstrate the deployment using Kubernetes with Helm. Lisa, anything to say before we end the session?
No, I would like to thank you both very much, all three of you. I'm sorry for for your contributions.